Hi friends, welcome to Chephy Master. Today we are going to start our CBSE syllabus classes. It is mainly focused on CBSE English medium classes and it is also helpful for state syllabus English medium. That's why let's watch my video. Welcome to Chephy Master. Please click on the subscribe button for subscribing my channel and please like my video and share my video. Hi dear students, my name is Shukur. I hope you are all safe and secure in your homes. Today we are going to discuss the first chapter of physics for the 8th standard, that is force and pressure. Are you interested in playing different games? Which type of games you are interested? Football? Cricket? Then hockey? Yes, you are very interested playing different games, aren't you? Yes, let us recall some of our everyday experiences in these games. What do you to do? Make a football move? Yes, you know the answer. Then if you are moving with that football slowly, then what do you do to make a moving ball move faster again? Yes, that is the answer. How does a goalkeeper stop a ball? Yes, you know very well. How do fielders stop a ball hit by a batsman in cricket? Yes, a hockey player changes the direction of moving ball with a flick of a stick. That is, yes, you have the answer. Yes. In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. In all these situations, the ball is either made to move faster or slower, or its direction changes. Direction of the motion changes. Yes. We often say that a force has been applied on a ball when it is kicked, pushed, thrown or flicked. What is force? What is a force? Do you know what is a force? What can it do to bodies on which it applied? We shall seek the answers to these such questions in this chapter. Okay, first we want to know that what is force. Do you know what is force? Yes, let's try to explain. Let's try to define what is force in your own answers. Okay, listen here. Action like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe a certain task. Aren't you? That means in any type of task, we are using push or pull. We are using push or pull. Aren't you? Yes. Each of these action usually result some kind of change in motion of the objects. Aren't you? Let's listen. This table is given. There is some action is made to be done. You have to complete this table. My dear children, to understand what is force means, you have to complete the table is given by me. That is, descriptions of situations. Identify the action as push or pull. Okay, in first situation, moving a book placed on a table. Then what is the action we'll do? That is pushing or pulling, picking, hitting, lifting, lowering, flying, kicking, throwing, shutting, flicking, etc. Which is the correct answer? What is the action we can do on the book which is placed on a table? That is given some, that is pushing. The pushing may be happen, and pulling, lifting. Then another action you can write on the blank. You can write another action you can write on the blanks. Okay, then action can be grouped as push or pull. If it push is there, then yes. Pull is there, then you can say yes. You can write yes. Okay, if there is no push or pull, then you can write no. That is the method to complete this table. Second situation, opening door or shutting a door. Opening or shutting a door. Third, drawing bucket of water from a well. Drawing a bucket of water from a well. And fourth, a football player taking a penalty kick. Taking a penalty kick. And fifth, a cricket ball hit by a batsman. A cricket ball hit by a batsman. Sixth, moving a loaded cart. Moving a loaded cart. Seventh, opening a drawer. In this example, you have to write what are the actions to be made on these objects. Maybe pushing, pulling, or lifting, like etc. You have to complete. Okay. Then in this action can be grouped as push or pull. Then if it push or pull is included, then you can write yes. If there is no push or pull, then you have to write no. Then if you are analyzing this table, you have understood that is, in all the cases, forces are applied in all the situations. Forces are applied in all the situations are given in the table. That means in all the cases are push or pull is happened. That's why we can define force with these two terms, push or pull. That is, force means, how can you define force? Force can be defined as a push or pull that experiences on an object. What is force? A push or pull that experiences on an object is called force. A push or pull, that is known as force. We understood that force is a push or pull on an object is called force. Then how can we apply a force on an object? How can we apply a force on an object? Suppose a man standing behind a stationary car. Okay, see the figure? A man standing behind a stationary car. This car is at rest. Will the car move due to his presence? Will the car move due to his presence? Not at all. Yes. How can he move the car? Suppose the man now begins to push the car. That is, he applies a force on it. The car may begin to move. In which direction? In the direction of force is applied. When the man applies a force on the car moves in the direction of force is applied. Yes? Understood? Yes. Note that the man has to push the car to make it move. Note that the man has to push the car to make it move. Let us observe the figure given to you. There are three figures. Based on these figures, can you understand my question's answers? Yes. You can decide who is pulling and who is pushing in this case of two figures. Two girls are pushing or pulling in these two figures. Who is pushing and who is pulling in these two figures? In figure 1, both the girls appear to push each other, while the pairs of girls in figure 2 are trying to pull each other. Similarly, the cow and the man in figure 3 appears to pull each other. The girls in the two situations shown here are applying force. Aren't you? Yes. The girls are applying forces on each other. It is also true for that man and cow. In the case of man and cow, they are also experiences force each other, isn't it? From this example, we can infer that at least two objects must interact for a force is experienced. That means without any interaction between two objects, we cannot experience a force between two objects. If there is no interaction between these two objects, we cannot experience a force. That is the condition for experience a force between two objects. Dear students, I explained that without any interaction between two objects, force cannot be experiences between these two objects. Then next we are going to discuss about the effects of forces. What can be done using a force on another object? That is effects of forces. What you can to do another object with your force? That's why you are going to discuss the effects of force. Here I list out these points, that is effects of force. Then here first point is force can cause motion in a stationary objects. If a body is at rest, if you apply a force, then the stationary objects, the object at rest, that may be changes to its motion. Isn't it? Next point, force can stop a moving object. If a body moves, then if you apply a force in the opposite direction of the moving object, then this body changes to the state of rest. From state of motion, this body changes to state of rest. Then third, force can change the direction of moving object. If a body moving in a particular direction, if he experiences a force in different direction, then the direction of moving body changes into different direction. That is fourth point, that is force can change the speed of a moving object. The force can change the speed of a moving object. That means if a body moving with a particular speed, and if you apply more force, or if you apply force on this object, this moving object, the speed of the body will be changed. Then for fifth point, that force can change the shape and size of an object. If you apply a force on an object, the shape of it maybe changes the shape and size of the object. And these 5 points we can explain with different examples. That's why we are going to each of these points. With the help of examples, we can understand what is the causes effects of the force. What is the effects of the force? First we are going to discuss the first point, that is force can cause motion in a stationary objects. Okay, that's why first point we are going to discuss that force can cause motion in a stationary object. That means force can changes the state of rest into motion. For example, a book is lying on a table, then you can move it by applying a force. That is, push or pull that exerted on this book. In that time, in the first time, book is in stationary. That means in the first time book is at rest. If you apply a force on this book changes into the motion. The state of book is from state of rest to state of motion, changes to from rest to motion. That is the example is we are written here. Force can cause motion in a stationary objects. Another case, if you are applying a force on a chair, in the first case, in the first situation, the chair is at rest. If you apply a force on the chair, then the chair will move. In that case, we can say that force can change a body state of rest into state of motion. That is, force can cause motion in a stationary objects. Another case, if a ball is kicked by a football player and he is focused to make the goal, then what will happen? In the first situation, ball is at rest. If the football player applying a force using his leg, then the state of rest of ball changes to state of motion. That is, force can cause motion in a stationary objects. That is, in the first situation, ball is at rest. After the player applying a force using leg, it is changes to motion. That's why we are first written as this: force can cause motion in a stationary objects. Okay. The second effect of force, we have written that force can stop a moving object. Force can stop a moving object. Okay, let us explain that. When a football player kicks the football towards the goal, then the goalkeeper apply a force to stop the ball. In which direction? To opposite direction of the motion of the ball. Okay, then what happened to the ball? Then the ball changes to the state of ball changes to rest. The state of motion of ball changes to rest. That's why we said that force can stop a moving object. In another case, if you are moving a bicycle, we apply if you apply brakes on the bicycle, then this bicycle comes to rest after some time. Here we apply a force on the bicycle tire using brake. That's why force can stop a moving objects. Another case, if a ball is moving in a horizontal floor and after some time automatically this ball comes to rest. How? If balls move in a horizontal surface like this, after some time this ball comes to rest. After some time this ball comes to rest automatically. How? Here a force is experiences by the floor where the ball is moves. That force is known as frictional force. Frictional force or friction. This frictional force is also in opposite direction of the motion of the ball, and here a force is applied by the floor on the moving object. That's why the ball comes to rest after some time. That is the case. We said that force can stop a moving objects. Force can stop a moving objects. The third effect of force is, that is, force can change force can change the direction of moving object. Direction of moving object. Okay. For example, when a batsman hit the ball with using his bat, the direction of the moving ball changes its direction. If a cricket player hitting a ball using his bat, then the direction of the ball changes. That's why we said that force can change the direction of a moving object. Here, cricketman apply a force on the ball using this bat. That means here direction of the ball changes. Direction of the moving ball changes. Okay. Another case. Similarly, when a tennis player returns a service, he or she uses a force to change the direction of the ball. In this case, force can change the direction of the motion of moving objects. That is, force can change the direction of the moving object. The fourth effect of a force, that force can change the speed of a moving object. For example, if you apply a force on a swing, then the speed of swing will be increases, isn't it? And if you apply a force on a moving swing in opposite direction, then the speed of swing will be slowed down. Aren't you? Yes, that's why we said that we can change the speed of a moving object. Another case, if you are applying more force on the pedal of the cycle, then the speed of the cycle will be increased. And if you apply force using brakes, then in opposite direction of the motion of the bicycle, then the speed of the bicycle will be slowed down. That's why we said that the force can change speed of a moving objects. Understood? Can you understand? The fifth case of the force, the effects of force, that is force can change the shape and size of an object. The force can change the shape and size of an object. That is the fifth effects of the force. That means, for example, if you are applying a force on a inflated balloon, the shape of the balloon will be changed, isn't it? Then we are applying force on the balloon. In the case, if you are applying a force on a paper, then the shape of, if it is crumbled, it changes to crumbled. That means the shape of the paper will be changed. In other case, if you apply a force on the toothpaste, then the shape of the toothpaste will be changed. If you stretch a rubber band, then what will happen? If you stretch a rubber band, then the size of the rubber band increases, the shape of the rubber band changes. And if you apply a force on the catapult, then the size of the rubber band of the catapult will increases. In that cases, we can said that force can change the shape and size of an object. And these 5 examples, in the 5 situations we are explained here, the effects of force. One is, force can cause motion in a stationary object. Second is, force can change a moving object. Then force can change the direction of a motion of a moving object. Then force can change the speed of a moving object. Then last, force can change the shape and size of an object. The 5 situations are the example for effects of force that can be make to be done on an object, if you are applying force on any type of object, you can feel, you can experience this type of changes. Understood? Okay, now I am displaying one of the table in front of you. The effect, to studying the effect of force on an objects. To studying the effect of force on objects. Okay, that in this table you can see that description of situation, how to apply force, and diagram is there. Then action of force. What action of force that be done on this object? That means change in state of motion or change in shape. If it's a change in state of motion, you can tick there, and if there is no change in motion, then you can tick on the column of no. And change in shape also like that. Okay, in first case, a lump of duff on a plate. A lump of duff on a plate. Pressing it down with your hand. How to apply force? Pressing it down with your hand. Then what is the action of force? And second case, spring fixed to the seat of a bicycle. And how to apply force? By sitting on the seat. Then what is the action of force? Next, a rubber band suspended from a hook or nail fixed on a wall. Then by hanging a weight or by pulling its free end. By hanging a weight or pulling its free end, then what is the action of force? You have to complete. You want to complete this table based on our study. Okay. The fourth example, the fourth situation, a plastic or metal scale placed between two bricks. By putting a weight at the center of the scale, then what is the action of force experiences on this object? You have to complete it. Okay. While a force may cause one or more of these effects, it is important to remember that none of this action can take place without the action of a force. Okay, we have studied that none of these actions, any actions, can be takes place without the action of a force. Thus, an object cannot move by itself. It cannot change speed by itself. It cannot change direction by itself. And its shape cannot change by itself. Okay. Without force, we cannot change. It is important to remember that none of this action cannot take place without the action of a force. That's why we are learned that effects of force. Do you follow me? Then I explained what is force, then what is the effects of force. What is force? Force is the push or pull on an object is called force. I have explained. Then here, what is the unit of force? Force is a physical quantity. That's why we have to experience in different situations. I explained that the effects of force also. And here, what is the unit of force? The unit of force is Newton. What is that? Newton. It is the name of one scientist. The letter represent the unit of force, that represent letter using the letter N, capital letter N. Then we can represent the unit of force using the capital letter N, that is Newton. Then what is 1 Newton? How can experience 1 Newton? 1 Newton, that may be equal to, if you are placing 100 gram, if you are placed 100 gram mass on your palm, then you can feel one weight on your palm. That weight is equal to 1 Newton. Okay. Then what is the unit of force? Unit of force is Newton and it is represented by capital letter N. Okay. I said that 1 Newton force is approximately equal to 100 gram. Weight experiences for 100 gram mass is equal to Approximately is equal to 1 Newton. Then what about 2 Newton? That means 2 Newton means the weight experiences for approximately the weight experiences for 200 gram mass. Okay, that is known as 2 Newton. Then what about 10 Newton? 10 Newton means the approximate weight experiences for 1000 gram, that is 1 kilogram, isn't it? That is 1 kilogram. Approximately that is equal to 1 kilogram. The exact value is that is 980 gram. 980 gram. That is exact value. That's why we can say that 10 Newton that may be is equal to 980 gram. Then this is approximate value. This is a exact value. Then here the force applied to lift an object of mass 1 kilogram vertically upward is called 1 kilogram force. It can be represented by 1 kgf. Okay, 1 kgf is equal to approximately that is equal to 10 Newton, that is equal to 9.8 Newton. 1 kgf is equal to 1 kilogram force is equal to 9.8 Newton. That is 1 kgf 1 kilogram force, that is equal to 1000 gram force. That means we know that 1 kilogram is equal to 1000 gram. Like that 1 kgf 1 kilogram force is equal to 1000 gram force. 1000 gram force. Okay. Can you understand? Yes. Okay, dear students, next topic is resultant force or net force. In our daily life situation, more than one forces that may be acted on an object. Okay, in several situation, more than one forces that can be applied on an object. In that case, we are discussing about the resultant force or net force acting on that object. For example, let us see, choose a heavy object like a big box or table, then which you can move only by pushing very hard, like this. So like a table, then you can only pushing this table very hard, and if you pushing the table very hardly, it will be moved. Okay, try to push it by yourself. Can you move it? Yes, very hardly you can move it. Okay, now ask one of your friends to help you in pushing it. Then your friend comes and he helping you to push the box or table in the same direction. Your friend also pushing in the same direction of in which direction you are pulling, in that same direction your friend is also pushing the box. Then can you then what happened? It is easier to move now? Yes. Now it is easier to move, isn't it? Why? Can you explain why? Yes, we here two forces are applying on the same object in same direction. For example, you are applying 40 Newton force, then your friend applying 50 Newton force. This 40 Newton force and 50 Newton force are applied in the same direction on the box. Then the resultant force or net force that acting on this table, just adding these two forces, that is known as resultant force. What is resultant force? The total force acting on an object when more than one force act on an object. In this box, more than one force is acted. One force is acted by you, that is 40 Newton, and another force is acted by your friend for 50 Newton. Then how can you find out the total force or resultant force or net force acting on its object? Just adding these two forces, because these two forces are acting in the same direction. If the forces are acting in the same direction of an object, then the resultant force or net force can be calculated by just adding these two forces. Then the resultant force, that is total force acting on this box, can be find out. That is resultant force or net force or total force acting on this box is equal to the force acting by you, the force acting by you, plus the force acting by your friend, Then what is the value of force acting by you? That is 40 Newton, plus then force acting by the friend is 50 Newton. That means the resultant force acting on this box is 90 Newton. This is the method to find out total force acting on the box. If these forces are in the same direction acting on same object, then the resultant force or total force can be find out simply adding these two forces. We can find out the resultant force. Suppose you and your friend had an argument. Your friend refuses to help you. He starts pushing the heavy box in the opposite direction by applying 40 Newton force. That is equal to your force. That is it. What I say? That is, if the box is here, then you are applying 40 Newton in this direction. Your friend also applying the 40 Newton force in this direction, opposite for your direction. Opposite of your direction, your friend is also applying 40 Newton. That means two equal forces are applying in two opposite direction on an object. Since both of the forces are applied at the same object but in the opposite direction, then the resultant force is calculated by the difference of these forces. That means the one force is subtracted from other force. That is the method to calculate when if the two forces are applied on the same object in opposite direction, we can calculate the resultant force by taking difference of these two forces. That means we can find out the resultant force, that is that is equal to 40 Newton minus 40 Newton. That is equal to 0. That means here the resultant force or total force experienced on the box will be 0. That means the box doesn't move. Because why? Because these two forces are equal but in opposite direction. That's why the box doesn't move. So we conclude that when two equal forces acting on an object in the opposite direction, the resultant force becomes 0 and the object does not move. Okay, and in this case, if the object does not move, that type of forces is also known as balanced forces. Here forces are balanced. That means it is also known as balanced forces. Here is balanced forces acting on this box. Okay, in this case. Suppose You push the heavy box with a force of 50 Newton and your friend apply 40 Newton force in the opposite direction. Then what will happen to this box? Okay, just observe that. If you are applying 50 Newton, you are applying 50 Newton force in this direction, your friend applying 40 Newton in this direction, opposite direction. Then what is the resultant force? Here is also the two forces are acting in opposite direction. That means we can find out, we can calculate the resultant force by taking the difference of these forces. That means here 50 Newton minus 40 Newton. That means here is the resultant force is 10 Newton. Okay, in which direction this resultant for 10 Newton will be experienced as? Direction of the resultant force will be in the direction of the force which is having higher value. The direction of the resultant force will be in the direction of the higher forces. That is the method we want to calculate. We can calculate the resultant force. So we can conclude that when two unequal forces acting in opposite direction on an object, the resultant force is found to be difference between the two forces. It moves the object in the direction of the large force. In the direction of the large force. Okay. In this case we understood that this object will move in this direction. That is means the object will move in the direction of the larger force. That means if there is a motion for this object, then these two type of force is known as unbalanced force. In that case, when two opposite forces are equal force, we say that is balanced force. If these two forces are unequal force in opposite direction, then we say that this is unbalanced forces. Unbalanced force. And here is unbalanced forces can move an object. That means unbalanced force that can only move an object. Balanced force doesn't move an object. Okay, another example for unbalanced force that can be explained that, have you ever seen the game of tug of war competition? In this game, two teams pull the rope in opposite direction. Members of both teams are trying to pull the rope in their own directions. Sometimes the rope simply doesn't move now. Doesn't move. Why? In that case, two teams are applying equal force in opposite direction. There is no motion for the rope. In that time, there is balanced force are experienced. But at last, when one team experiences apply more force than other team in their own direction, then that team finally wins. The team that pulls harder and largest force is applied into one direction, that team finally wins the game. Okay, and here when the unbalanced force experienced in the tug of war competition, in that time one team wins the game. Okay, that is the example for unbalanced forces. Okay, dear students, let's conclude our classes. That means we are discussed that what is force, then what are the effects of force. What is force? A push or pull on an object is called force. Then what are the effects of force? Force can move a object as stationary. Then force can changes to rest a body in motion. A force can changes the speed of an object. A force can changes the direction of a moving body. A force can changes the shape and size of an object. Then we learned that the unit of force is Newton. And last we are discussed about the resultant force, net force, that is the total force acting on an object. There are more than one force acting on an object. The resultant force, if the two forces are acting in same direction, then the resultant force will be calculated by simply adding these two forces. If two forces are experienced on an object in opposite direction, then we can calculate the resultant force by taking the difference between two forces. Okay, and if two forces are equal force in opposite direction, that type of force is known as balanced forces. Then if two unequal forces are applied on an object in different in the opposite direction, then that force is known as unbalanced force. That means balanced force doesn't move any object, but unbalanced force only can move an object. That is our conclusion. Okay, thank you for watching my video.
First question, analyze the given figure and write down in the table below the result of applying force on different objects. Second question, third question, observe the following figure and complete the table, then answer the following questions.